Okay, so this is 3.3 linear constant. We're not actually doing exponential equations right now, not in this video. Um, and then I'm on page M148. Okay, so if we look at this, it's talking about increasing functions and decreasing functions. So, and then constant functions. So we have been talking about increasing functions and decreasing functions in the fact that we have been talking about slope. So an increasing function, let me get a different color. So an increasing function is as you move from left to right, the function goes up. That's why it's called increasing. So we've been looking at it in the fact that it goes up like that. It has a positive slope. Okay. Decreasing function would be the opposite. X, Y. It's when it has a negative slope. Okay, so positive slope is an increasing function or negative slope is decreasing. So I'm going to actually put that, let me see if we had any room on our vocabulary page the other day. I didn't have any room. So I'm going to put it at the bottom. This is actually what we're going to be doing in just a second. But, so I have linear functions, constant rate of change, and increasing, decreasing functions. And then I have two categories, linear and nonlinear. We're going to write that in just a minute. But I'm going to go ahead and put down here below it, increasing function when the relationship goes up from left to right. Now, if you notice on this graph, when you have as, I'm going to also write it as the x increases, the y is also increasing. So they're both increasing together. So as x increases, y increases. And you can see that, sorry, my foot got turned. As I move from left to right, which is what we said, that's x increasing, the y value is increasing. This one, as I move from left to right, as the x increases, these y values are going down. So that's another definition for increasing. And then I would draw a picture somewhere, just like we did. Oh my goodness. Don't ignore that. No, do ignore that, but I'll wipe that out after the video. So increasing function looks like that. Now let's write decreasing function. Okay, so decreasing function when the relationship goes down from left to right. So as x increases, the y decreases. So that one said increase, that one says decreases. And then let me draw the graph. So that's what decreases looks like. Okay. All right. So now, oops, just dropped a bunch of markers. So now I'm going to go to page M156. So page M156. And we're going to actually do what I had in that notebook, but I'm going to do it on this graph. So linear, and then this is non-linear. Okay, and so I'm going to draw a few examples. So this one is a linear equation. Notice it has a straight line, so that's what makes it linear. Okay, you can also have a decreasing function. Okay, so x, y, so if I have 0, 1, 2, 3, 4, I could have 5, 10, 15, 20, 25. It has to be here because of that definition right here, constant. If the value of the dependent variable remains constant over the entire domain. So notice this goes up by 5 each time. That's what makes it linear. You should have noticed when we were talking about linear a little bit in the last little bit, or whenever we did, I can't remember. I can't remember how many videos ago it was. But if the slope was the same, so like if I'm going up 5 and over 1 and up 5 and over 1 and up 5 over 1, that's what makes it a line because it's constant. So constant. Okay, it can also be linear even if it was just single points. It still forms a line. Okay, nonlinear would be if it looked something like that. That's not linear. Okay, not linear could also look like a U. That's not linear. You could have one that looked like that. Notice those are not linear. It's not a constant rate. This one is going down, 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 and then all of a sudden it starts going back up. So it's not constant. This one, same thing. It's kind of going down quickly, and then it starts going down a little bit slower, and then it starts picking up and going up the other direction. This one is really, 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 really slow, and then it starts going really, really fast. So those are not constant. Okay, another one is if I just had random points all over a graph, that's not constant. If I have a table that's not constant, it could be like 0, 1, 2, 3, and then it could be 4, 2, 5, 3. It's not constant. These numbers keep changing. That's 2, that's 3, that's 2. It's, yeah, it might look like it's in some sort of pattern, but it doesn't matter. It's not an increase or a decrease constantly or consistently. So these are all for linear. These are descriptions when it is linear. So when it's increasing, decreasing, or constant. So increasing means it has a positive slope, just like we talked about just a second ago. Decreasing is a negative slope. And then constant. Constant, it's right there. That's where we use the constant slope or rate. Okay. Domain and range. So if you look at these linear problems, if you look, and these should really have arrows on them. So notice there is a -3, there's a -2, there's -1, but that's not where it stops. It would have a -4, it would have a -5. It has a +1, a +2, a +3, +4, and it would keep going. So then our domain is all real numbers. The range notice this is at like -3, -2, -1, 0, 1, 2, 3, 4. It would keep going 5, 6, 7, 8. This one would have been lower, so it would be all real numbers. Okay, the only exception to that is when they're just single points like this, but typically they're not. You rarely see them where they're just points exactly like that. Maximum and minimum, we will be talking about other types of functions later on, not right now, but maximum and minimum, there is no maximum point. This would keep going, and this would keep going, this would keep going, this would keep going. There is no maximum point, or at least typically no max or minimum. There is a type of function that definitely has a maximum and minimum, but we're not going to talk about those, at least not yet. Curve or line, it is a straight line. So those are, and hopefully that fridge or whatever it was wasn't too loud, but so it's a straight line. So that's what makes it, that's why it's called linear. Okay, so that is the characteristics of linear functions.